All right, Miss Teasley here. This is section 2.1, basic functions and their graphs. All right, so let's get started. A relation is a set of blank blank, which is ordered pairs. So we're going to put in here ordered pairs. A function is a relation in which for each distinct value of the first component of the ordered pairs, there is exactly one value of the second component. So exactly one value. So distinct for every single x value. They're all different. There's only going to be exactly one value of the second component. All right, so if the value of the second component y depends, keyword depends, on the value of the first component x, then y is the independent variable. Y is the dependent variable. All right, so this goes dependent. So y depends on the value of the first component x, then y is the dependent variable, and x is the independent variable. All right, so what this says here at the top, all right, so basically we're going to use this example to explain this about the difference between a relation and a function. So a relation, set of ordered pairs. If you notice M, N, and P, you have sets of ordered pairs. Now it says decide whether each relation defines a function. So to determine that, you look at your x values. That's all you care about are your x values. So I'm going to actually highlight my x values. So here in M, I have a -4, -3, and 3. Since they're all different numbers, that means that M defines a function. So this is a function. It's as simple as that. None of the x values repeat, so you have a function. Let's look at letter N. The relation N, I have a 2, 3, 4, and 5. You don't care anything about what's going on with the y values. You want to look at only the x values. If you notice, I have x values 2, 3, 4, and 5. They're all different. Therefore, N represents or defines a function. Down to letter P, I have a -4, 0, 2, and then -4 shows up again. So you have the point -4, 3, and you have the point -4, -3. All right, so -4 goes with 3 and -3. So therefore, since this -4 pops up twice, this is not a function. So again, just look at your x values. If it repeats, it's not a function. If none of the x values repeat, then you have a function. So let's make a little note here. So in case you look back, this is not a function because -4 repeats. So this is your reason. I'll move it down a little bit so you know it goes with that. All right. So in a function, no two ordered pairs can have the same blank blank and different blank blank. So in a function, no two ordered pairs can have the same x value and different y values. So no two ordered pairs can have the same x value and different y values. So I guess that would be S. All right, in a function, there's exactly one value of the blank variable, which is the second component. So that lets us know this is a y variable for each value of the x variable, which is the first component. So there you have it. That's the definition of function. You're going to see functions. You're going to hear the word function come up a lot. So it's important that you understand what a function is. Now we have domain and range. For every relation consisting of ordered pairs x and y, there are two important sets of elements. The set of all values of the independent variable x is the domain. The set of all values of the dependent variable y is the range. So the way that I remember is that an ordered pair is x comma y. So x comes before y alphabetically. So then I look at it the same way as domain. All right, so D and R. All right, so this is domain. Domain comes first in the alphabet, or D comes first and then R comes second. So domain and range. That's the way I remember. So X and Y in that order. Just look at, make sure alphabetically X goes before Y, D goes before R. There's your domain, your range. Domain corresponds with the X values. Your range corresponds with your Y values. Okay, so let's look at an example. All right, hopefully the example makes more sense. Find the domains and ranges of relations. Give the domain and range of each relation. Tell whether the relation defines a function. So the domain, when they say to give the domain and they give you a set of ordered pairs, like in example A, all you care about are your x values. You want to list all your x values. So I have -4, -1, 1, and 3. So I'm going to list those numbers, -4, -1, 1, and 3. That's my domain. My math lab would give you the little fancy symbols, the set notation. You just have to type the numbers in, separated by commas. The range would be your y values. Just a list of y values. You don't repeat. If any of the numbers repeat, you don't write it twice. You just write it once. In this case, I have a y value of -2 first, then 0, then 2, and then 5. So that's your domain and range. That's the first part of your answer. Then it says, tell whether the relation defines a function. So that goes back to the previous example. Notice how I have all my x values highlighted. And to determine if it's a function, none of the x values can repeat. So if you notice, in example A, none of my x values repeat. So yes, this is a function. That's how you determine. All right, going to B. B is what we call a mapping. So looking at B, I like to write out my mapping, like actually write these as an ordered pair. So as ordered pairs. So basically, if you notice, 1 has a line going from 1 to 4. This is your X circle and your Y circle, your domain and your range. So this is actually your domain values. And these are your range values. So when they ask you for domain and range, it's the numbers in your first circle. That's your domain. The numbers in the second circle are your range values. Now to write these as ordered pairs so we can actually see what we're working with, if you notice there's a line from 1 to 4. So this is 1, 4. That's that ordered pair. And then from 2, you have a line going from 2, 5. So that's 2, 5. And then there's also a line coming from 2 that goes to 6. So that'd be the point 2, 6. And then you have this other point goes from 3 to 7. So that's how you write it in ordered pair form. So the mapping here corresponds to the list of ordered pairs I have there. So they asked me for domain or range. Domain, again, is all the numbers in your first circle. All right. Or if we want to highlight, look at all your x values. So my x values are 1, 2. 2 pops up again. You only write it once. So it'll be 1, 2, and then I will go to 3. You don't want to write the 2 twice. Okay? So when it comes down to listing your domain, even though it shows up twice when it's in ordered pair form, you only want to write it down once. So your domain will be 1, 2, 3. Again, it's the first circle, all the numbers in the first circle. And your range would be the numbers in your second circle, which is 4, 5, 6, and 7. And if you go down the line and look at all your y values, that's why I got the 4, 5, 6, and 7. Now, talking about the fact that the 2 repeats. Since the 2 repeats, that means this is not a function. All right, so that's repeats. Let me highlight that. Maybe use a different color. So I'm saying that this 2 repeats. And so therefore it's not a function. The yellow stuff goes together. Alrighty. Looking at letter C. All right. Letter C, you look at they have the table and they have an X column and a Y column. We can write these as ordered pair. This would be -3, 5. This is the 0.05. This is the 0.35. And then we have 5, 5. So those are all the points, the ordered pairs. Now the question is, what's the domain range? And it's to determine whether or not this is a function. So your domain will be only your X values. So I have, again, I'm going to make sure none of these repeat. I have a -3, a 0, a 3, and a 5. Those are all different. So my domain will be -3, 0, 3, and 5. It does not matter if you put these in the correct order. I mean, everything is nicely set up where the numbers are lining up and they're actually in order from smallest to greatest. So if you don't put them in order, my math lab will not mark it wrong. So if that's the question that you have, that's fine. You don't have to put it in the correct order. All right, going to the range. The only Y value I see is 5. And even though it's written 4 times, I'm only going to write it once when I give my answer. So when they ask me, what's the range? My range would just be 5. That's the only Y value that I have. Because -3, 0, 3, and 5, they're all distinct. They're all different numbers. That means that this is a function because none of those values repeat. So this is a function. So function, this is not a function, and this was a function. All right, so hopefully you have a clear understanding of what a function is. All right, so going down to example 3, finding domains and ranges from a graph. So let's make a note. So domain is your restriction on your X values. All right, so domain is your restrictions on X. If it's a nice continuous curve or a graph like B, C, and D. All right, we'll talk about A shortly, but B, C, and D. If you see graphs like B, C, and D, this is going to be how wide, all right, the graph is. So I go from, I'm looking at X values, how wide, this is what you ask yourself, how wide is the graph? All right, so from what to what makes it wide. So it's the width that you're looking at. And then the range will be my restrictions on Y. And then I ask myself, well, how tall? So how wide, how tall? That's the way I remember domain and range. So we'll get to that part in a moment. But here, if you look at letter A, this is what we call a graph. You have these points here. This is discrete. So it's not connected. So you just have these 4 points. So if you look here at these 4 points and they ask for your domain or range, well, if you notice, they already have all the points listed for us. This would be just like from before. I have the point -2, 3. I have the point 4, 3. I have the point -2, 0, and the point 4, 0. The domain, if you look at all your X values, the only X values I see are -2 and 4. So that would be your domain. The range would be the Y values. The Y values would be the only 2 Y values that I see, right? Looking at these 4 points would just be 3 and 0, right? So 3 is up here, 0 down here. You can put 3, 0 if you want to put them in the correct order and make it 0, 3. That's fine. So that's your domain or range. All right, so getting down to the other types of graph. how wide, how tall. So when you see this graph, first of all, you have an arrow on both ends. That means this graph never ever ends. This graph, this line is made up of infinite many points. Like I can't even darken in all the points that make up this graph. All right, so it's all the points. So there's infinitely many points that make up that line. So let me label. So when you look at your x and y axis, down here you have negative infinity on your x axis. So they don't write all the numbers. They only have this little box, this little portion. But if I was to keep going, this will go all the way out to negative infinity. Over here, this is positive infinity. On the y-axis, up here is positive infinity. All right, so if you keep going and numbering your y-axis and going all the way up, you would go to infinity. If you start from the origin here in the middle and count down all the way down on your y-axis, this will lead you to negative infinity. So most of the time, I kind of write this off to the side to help me with my domain or range if I need to. So when you ask yourself, well, how wide is this graph? When they ask you for the domain, how wide? If I only look at x values, what would make up how wide this graph is? So you have this arrow. This arrow would keep going on and on and on and on. All right, I'm kind of putting a little... It would never end. So then when I say, well, how wide? Basically, what x value would go with these points? If I kept going on and on and on, what x value, all right, would actually start off this graph? Well, it would keep going on to negative infinity. And on the right side, if I keep going this way, all right, it's increasing going that way, and it would end at positive infinity. Like it goes from negative infinity to positive infinity. It never ends. There's no restrictions on x. It goes from negative infinity to positive infinity. That is your actual domain. Negative infinity to positive infinity. The same thing goes for range. How tall is this graph? This arrow points up. Well, what's up there? All the way up there is positive infinity. You're looking at y values. Down here, if I keep going all the way down here, whatever down there is, that's going to be negative infinity. So my range is also negative infinity to positive infinity. So a graph that looks like that keeps going on both sides, would be negative infinity to positive infinity. That's the domain or range of that particular graph. All right, so just ask yourself how wide, how tall. Let's look at letter C. All right, letter C may make more sense to you. If you look at letter C, when I say domain, I'm saying, well, how wide is this graph? And when I say how wide, I'm using x values. So x values. So from what x value to what x value? Well, this graph stretches out from here to here. So it goes from, it looks like this is -5 to +5. So that would be my domain. So the way that you write it is you put brackets, because -5 and 5 are both included. Those are actual values in your domain. So you would go from -5 and you put comma 5. That's your domain. So my graph would be if I wrote down all the points, if I actually could write down all the points on this curve, it would start with -5 and it would end with 5 and all the numbers in between. So that comma represents all the numbers in between. That's your domain. So that's how wide that graph is. And when you look at range, well, how tall is it? If you look at it on the y-axis, right, in this version, y, here to here. That's about how tall that graph is. So when you write down your domain and range, all right, range is going to be your y values. You have to put it in the correct order. So you would say that it starts at -3. -3 is the smallest number, and it goes all the way up, all right, to 3. So my range would be bracket -3 to 3. You're always going to use a bracket unless there's some type of hole or something there. But in this case, it's not. So this would be from -3 to 3. Now, letter D kind of combines B and C together. So let's look at this example. So again, you see these arrows, you make sure, those arrows keep going on, like it never ends. All right. So I'm kind of putting a little, that it's going to keep going in that direction. It gets wider and it keeps going down. So when I look at my domain, I say, well, how wide is this graph? Well, if I kept going on this side and that side, all right, notice how I'm kind of like trying to show you that the graph never ends. Let me do this. So this graph arrow means it keeps going, but it's going to keep getting wider also. All right, I don't know if I keep going all the way down here to infinity. I don't know how wide, what x value that arrow actually corresponds to. Remember, this goes from negative infinity to infinity. Same thing here. This is infinity and this is negative infinity. So looking at this graph, all right, looking at this graph, it looks like my domain would be from negative infinity to infinity. So those arrows, if you look at how wide the graph is, all right, it doesn't stop. You have arrows on both sides that would keep going. That's your domain. Negative infinity to infinity is similar to letter B. The range, again, these arrows is going down here somewhere, whatever that is down here, which the lowest y value, how tall, it goes from negative infinity, because down there's negative infinity, but it also goes all the way up. It doesn't go to infinity. It actually stops here at this y value. That y value, if you look at the y-axis, that y value is 4. So my range starts from negative infinity. You always put parentheses around infinities. All right, negative and positive infinity. But then it reaches all the way up to 4. So you put a bracket around 4. All right, I only use parentheses because I was talking about infinity. All right, the 4 is included, so you put a bracket. Those can be a little bit challenging. The more you do, the better you'll get with reading the domain and range from a graph. All right, so determine whether relations are functions. All right, so determine if a relation is a function. We use something called the vertical line test. So let me go back up here to, well, let's talk about, because they actually use the same examples from above. So it says, if every vertical line intersects the graph of a relation in no more than one point, then the relation is a function. All right, so this is point. So letter A would be the perfect example to use to determine whether or not something is a function. So let's go by what we know. So let's look at the order pairs. So the order pairs, I'm just going to write down all the order pairs that make up this relation or this graph. So this would be -2, 3. Then I have 4, 3, -2, 0. So I'm separating these by comma. And then I have 4, 0. All right, let me move this out so you can see it a little bit better. I'll put it maybe here. All right. So these points correspond to this relation here. So if I needed to determine whether or not this relation represented a function based on prior knowledge on what we talked about earlier, I will look at all my x values. I see -2, 4, -2, and 4. Well, -2 and 4 both repeats. So I definitely know that this is not a function. So that's based on what we talked about earlier about looking at the order pairs. But they have something, we can use something called the vertical line test if we're looking at a graph, which means that if I put an imaginary, so remember this is like an imaginary vertical line. If you put a vertical line anywhere on this graph, if it hits more than one point, it's not a function. So let's just see. So if I put an imaginary vertical line like here, if you notice, it hits a point here and it hits a point there. It hits both of those points. It hits the point -2, 3 and -2, 0. And what do they both have in common? They both have the same x value, the same x value of -2. So that's why we use a vertical line. So if I just put any imaginary vertical line, so just imagine, me just putting this imaginary yellow line on this graph, it's going to hit more than one point at a time. So if it hits more than one point at a time, it's not a function. All right, if you notice, these are the same examples from before. Looking at letter B, this graph is made up of a whole bunch of points. Remember, infinitely many points. I couldn't even write down all the points that make up this graph. But if I was to put any type of imaginary vertical line on this graph, it's only going to hit one point at a time. Like if I imagine I'm putting this green line here. I'm only going to hit one point at a time. I'm not going to hit a point above and below. Hopefully you can see that. You're only going to hit one point every time you put a vertical line on this graph. So in letter B, this will be considered to be a function. Letter C, well, look, if I start darkening points, just any points, if you notice, you're going to hit more than one point if you put a vertical line. So if you can put a vertical line anywhere on this graph and it hits more than one point, then it's not a function. So something like here, it's going to hit this point up here at the top and the one at the bottom. So this is not a function. So part C, this is not a function. When you look at letter D, I can darken in as many points as I like. And hopefully by now you can see that if you look at this graph, I don't have any points that overlap. So that's basically what happens. You don't have any points that's going to overlap. So if I put a vertical line on this graph, it's only going to hit one point at a time. So things that are not functions are graphs that kind of curve around, like in this case here. From letter C, they curve around. That wouldn't be a function. But letter D, this is a function. So if I had like a sideways parabola, let me just draw another example. This would not be a function. Right, because if you can hit, you have points that overlap. I can hit a point here and here. So that would be not a function. So hopefully that extra example will help. All right. So next examples is you should be able to look at an equation and determine whether or not it's a function. So what you want to do when you have, so the ones that you'll see in this class, just look at the variable y, right? So that's y to the first. This is y to the second. This is y to the second. I'm just darkening in all my y values. And then here, this is y to the third. So any equation that has an even exponent for y is not going to be a function. I'm going to show you all these in Desmos, so we'll look at it on a graph. So basically, if y, the variable y, has an even exponent, then it's not a function. All right. Then it's not a function. So this would be a good example to look at it using the equation, and then we'll also look at it using the graph like we did before when I talked about using a vertical line test. So let's just see if we're correct. So the first one, I'm saying basically if I look at this equation, this is y to the first power. Y1 is an odd number, so therefore I'm saying that this is a function. As simple as that. That's a function. Then I said that this one has a y squared, so this is not going to be a function, so not a function. Again, we're going to check all these using Desmos. We're going to graph it, and we're going to check to see how the graph looks and how it matches up. This is x squared plus y squared. This is a 2, which is an even exponent, so this is not a function. And then I have y to the third power. 3 is an odd number. That's not even, so therefore this is a function. So I'm going to just put these into Desmos. So let's check and see. So the first one is x squared plus y equals 1. So x squared plus y equals 1. All right, that's your graph. All right, remember on Desmos, if you tap the point, to show you points. But this passes the vertical line test, so this is a function. All right, the next example, I have to look and see. The next example was x plus y squared equals 1. So let's see. X plus y squared, so I'm going to delete this out. X plus y squared equals 1. I said this is not a function. And if you notice, you have this sideways curve. You're going to hit more than one point at a time. So that is not a function. And I knew that just by looking at the equation because I saw that y squared. And then let's go here. We have x squared plus y squared equals 1. So let's see what happens when I put this in. X squared plus y squared equals 1. All right, so you got that little circle there. So definitely it's going to hit more than one point at a time. All right, so this is not a function. Again, I saw the y squared. I knew it was a function. It was not a function. And then lastly, x cubed plus y cubed equals 1. So let's see. I'm saying that based on the equation that it is a function. So let's see what happens. So x to the third. You hit the little a to the b power that gives you your exponent. So a to the third and then plus y, hit this button here, to the third power equals 1. All right, so there's that's a nice little interesting curve. All right, so definitely if I darken in all the points, on this graph, I'm only going to hit one point at a time. So this would be considered a function. So again, just look at the exponent for the y variable. All right, so now let's talk about this function looking at a graph. So they have this f with the x in parentheses. Notice how f of x is in the same position as y. So basically, f of x is the same thing as y. So that's called function notation. So this is function notation. So we have a graph, we have an x and we have a y-axis. So what they're asking you, so if you look here I'm going to explain what this means. When they say f of -2, they want to know what is the y value when x equals what's in parentheses, which is -2. That's what you're trying to find. So what is the y value when x equals -2? So when you look on this graph, you find x equals -2. All right, so x equals -2 is here, down here. X equals -2, that point, that has a y value of -2. So the answer to this would be -2. I'm going to write it on this side because I don't have enough space. So it's -2. So that's what you're asking yourself each time. What's the y value? So you're looking for a y value, and they tell you the x value in parentheses. So when x equals -1, the y value is -1. So in my math lab, you would just type in -1. F of 0, when x equals 0, all right, so it looks like this graph, it doesn't really show up that well, but this graph is connected. They didn't darken in the point when x equals 0, but if you read it off the graph, if you look here, x equals 0 is in the middle. That corresponds to a y value of -1. F of 1 has a y value of -1 also. And then f of 2, so when x equals 2, the y value is 0. So that's how you read function notation. That's how you answer the questions. So what is the y value when x equals whatever's inside the parentheses? That's what you're given as your answer. So f of -2, the y value is 4. So this would be something where I will pause the video and try them on your own and then come back and continue on with me. So f of -2 is 4. That means when x is -2, the y value is 4. F of -1 is 1. When x equals -1, the y value is 1. F of 0 equals 0. When x equals 0, the y value is 0. F of 1 equals 1, because when x equals 1, the y value is 1. And then f of 2 equals 4, because when x equals 2, the y value is 4. So that's evaluating a function by using a graph. Now we're going to look at, well, how do you evaluate a function if they give you an equation? All right. So I'm going to slide this up some. So to evaluate a function, what you would do is you take the equation that they give you here, this f of x equals x squared plus 2x plus 1. Remember, whatever's in parentheses represents your x value. So to find out what f of 4 is, then what you do is everywhere you see an x, you're going to put in the number 4. So I'm going to take this equation, which is x squared, but I'm not going to write the x. I'm going to leave it as a blank space and put parentheses squared plus 2 times parentheses plus 1. Because everywhere there's an x, I'm going to replace that x with a 4 in this example. So in place of those parentheses, I'm going to put in a 4. So the answer to this is 4 squared, which is 16, plus 2 times 4 is 8. Oh, didn't mean to do that. 2 times 4 is 8, and you have plus 1. So adding this across, 16 plus 8, 24 plus 1 equals 25. Oops. I didn't mean to do that. Now, I'm going to do the examples where they only ask you to find f of a number. So the next examples has f of negative x and f of x plus h. We will do those, but I want to just show you how you would do these without, I will show you how to do these because I want to show you how you can use Desmos to help you. So let's look at this example here. Here I have f of x. Sorry about that. All right, so the next example, I have f of x equals x squared minus x minus 6. So this is the example that I'm referring to. So it says find f of negative 3. Again, this would be something that you can pause the video and then you can try this on your own. But wherever I see an x, I'm going to put a blank parentheses. And then inside the parentheses, I'm going to put negative 3. So when I simplify this, I get negative 3 squared, which is positive 9, minus a negative 3 becomes plus 3, minus 6. 9 plus 3 is 12, and 12 minus 6 is 6. So that would be your answer. So I want to show you, we're not going to do this example here. Just close this out for right now. But I want to show you how you can use Desmos to help you evaluate these functions. So you can use function notation in Desmos. So let's look at it. So the first example, f of x equals x squared plus 2x plus 1. So go to Desmos. You actually go to the keyboard and type f. And you need to put your parentheses. So f parentheses of x. All right, so it closes off the parentheses for you. So over here, I come out here, I'm just clicking beside that parentheses. I'm going to put equals, I believe it was x squared plus, I forgot already, x squared plus 2x plus 1. All right, that's the graph. We don't care about the graph. We want to know what f of, what did they ask us to find? Oops. It was, all right, my apologies. They wanted me to find f of 4. So x squared plus 2x plus 1. They want us to find f of 4. When we did it by hand, I got 25. So I'm showing you how Desmos can calculate this for you. So going to Desmos, to find f of 4, you would hit enter. So you need to keep the f of x there. But then below it, you would type f, And then in parentheses, you will put 4. And notice how it says equals 25. That's your answer. So you can use Desmos to help you evaluate functions, only when there's a number in parentheses. So the next one, when you do that example, check it using Desmos. And if it's correct, you should get, if I did it correctly, we should get 6 when we put this into Desmos. All right, so definitely try that. Now let's go and look at these examples where they ask you to find f of negative x. All right, how would we do that? You would do the same thing. You would take the only side of the equation you worry about is the right side. Says x squared plus 2x plus 1. So I'm going to, again, rewrite the equation without x. So parentheses squared plus 2 parentheses plus 1. Well, what goes inside those parentheses? Well, what goes inside those parentheses is a negative x. That's what we're going to put over there, negative x. So in those blank spaces, I'm going to put a negative x. So you start off with blank parentheses. Don't even look at the fact that they're asking you to find f of negative x. Just start off every problem the same. You put blank parentheses wherever you see x, and then you look and see what's inside the parentheses, and that's what you put inside your parentheses. So negative x squared now, negative x times negative x is positive x squared. Positive 2 times negative x is negative 2x, and then you have that plus 1 at the end. This is your final answer. If I were you, I would pause the video and try this example, f of negative x. So again, I'm using the f of x function that they give us, x squared minus x minus 6. So parentheses squared minus parentheses minus 6. And then inside the parentheses, I'm going to put negative x. So negative x and negative x. Well, negative x squared is just positive x squared. Negative times negative x is positive x, and then you have the minus 6 at the end. This is your final answer. And then the last example, we have to find f of x plus h. Again, try not to look at this x plus h, all right, because you'll make it more, it'll seem like it's more complicated. But if you go through the same process, the process is, okay, I have a f of x at the top, and wherever I see x, I'm putting blank parentheses. So I have a parentheses squared plus 2 parentheses plus 1. Then this is when you go over here and you say, oh, well, inside of this parentheses, they have x plus h. This x has nothing to do with the x that was originally there. Just blank parentheses and then write down what you see. I see an x plus h. And then you have to simplify this. All right, when it says x plus h squared, this is the same thing as x plus h times x plus h. So you just can't square the x and square the h. You actually have to multiply that. I like to write it twice. I'm going to distribute this. 2 times x is positive 2x. 2 times h is positive 2h. And then you have the plus 1. Here, I'm going to use FOIL method. X times x is x squared. And then x times h. Whenever you're multiplying variables, all right, it's best to put them in alphabetical order. So when I do x times h, I'm going to write plus hx. Then I'm going to come back and multiply everything in the second parentheses times h. H times x, again, put them in alphabetical order, plus hx. And then h times h is h squared. And then you still have the stuff here beside it, which is plus 2x plus 2h plus 1. I know it looks like a lot, but this is the process, and this is how your answer is going to look. Here, the reason why you want to put your variables in alphabetical order when you multiply is so that you can clearly see that these two are like terms. I have a hx and another hx. So basically, I have two of these. This is h squared plus 2hx plus h squared plus 2x plus 2h plus 1. I'm going to check the problem, scan, and make sure I don't have any like terms, and I don't. So this long answer is what you will put into My Math Lab. That would be your final answer for that. And this is going to come back. We're going to end up using this formula again in the next section. But again, at this point, I will pause the video and try your example here. Find f of x plus h using the function that they give you. So hopefully you paused the video and you tried it. And now this is the solution. So parentheses squared minus parentheses minus 6. Those parentheses represents the x that was in the original problem. And inside the parentheses, I'm going to put x plus h. Remember, x plus h squared is x plus h times x plus h. And I have this minus sign in front of this parentheses, so this becomes minus x minus h minus 6. All right, to save time, I already multiplied x plus h times x plus h. I did it up here. And when I multiply all that out, I end up with this x squared plus 2hx plus h squared. So if you multiply this out again, you're going to get x squared plus 2hx plus h squared. So I'm not going to go through that process again. And then behind it, you have this minus x minus h minus 6. So this will be your final answer. All right, and again, I left this example off. Feel free, let me erase it. Feel free to do this example as some extra practice. But that's it. All right, guys.